In the hidden worlds beneath our feet, a real-life drama unfolds, one that most of us never even notice as we walk through the woods. The villain of this story? A fungus called Ophiocordyceps unilateralis, better known as the infamous zombie ant fungus, a name that hints at its chilling abilities. This master puppeteer targets a specific ant species, transforming it into a living vehicle for its own survival and reproduction. The process is both horrifying and fascinating, a true marvel of evolutionary adaptation. It all begins when a single microscopic spore lands on an unsuspecting ant, attaching itself to the ant's tough exoskeleton, and then drilling inside with relentless precision. The fungus doesn't kill the ant right away. Instead, it multiplies quietly, weaving a network of mycelia throughout the ant's body, slowly taking over from within. It releases a cocktail of chemicals that hijack the ant's nervous system, controlling its movements like a puppet master, while leaving the brain mostly untouched so the ant can still function. The ant becomes a prisoner in its own body, cut off from its colony and unable to resist the fungus's commands. Compelled by the fungus, the ant abandons its colony and climbs a plant stem, driven by an urge it cannot understand or fight. The fungus guides the ant to a precise spot, about 25 centimeters above the ground, where temperature, humidity, and light are just right for the next stage. The ant clamps its mandibles onto a leaf vein in a death grip, locking itself in place, remaining attached even after death, ensuring the fungus's safety. With its host secured, the fungus consumes the ant's organs for nutrients, breaking down the body from the inside out. Then a long stalk erupts from the back of the dead ant's head, a grotesque but vital structure for the fungus's life cycle. This stalk grows for days, forming a fruiting body filled with thousands of new spores, each one a potential new invader. When mature, it bursts open, raining spores onto the forest floor below, ready to begin the cycle again. Each spore is a new beginning, ready to infect the next wave of ants that pass by, continuing the fungus's legacy. The cycle of manipulation continues, a chilling testament to nature's ingenuity and the complex relationships that shape life in the forest. This is not science fiction. It's happening right now in forests around the world, hidden in plain sight beneath the leaves. The zombie ant fungus is a reminder. Sometimes the most terrifying monsters are microscopic, lurking where we least expect them. In the world of Ophiocordyceps, survival means control, and the struggle for life and death plays out on a tiny yet epic scale. And the drama never ends as the puppet master fungus continues its relentless quest for survival, one ant at a time. Now let's imagine the unimaginable. What if a force of nature, so small and yet so powerful, could cross the boundaries that separate us from the insect world? Could this puppet master, the Ophiocordyceps fungus, ever leap from ants to humans, rewriting the rules of infection as we know them? The barriers are immense. Our bodies are nothing like an ant's. Our skin, our cells, our very biology are worlds apart. Our warm temperature and complex immune system are formidable defenses, acting as vigilant guardians against invaders. For Ophiocordyceps to infect us, it would need to evolve dramatically, changing its very nature at the genetic level. As global temperatures rise, fungi are adapting to survive in warmer environments, inching closer to thriving inside the human body. A heat-tolerant strain could be the first step, a crucial adaptation that opens new doors for survival. Next, it would need to evade our immune system, perhaps by developing a protein cloak or chemicals that suppress our defenses, slipping past our body's alarms. The fungus would also have to rewrite its chemical language, creating entirely new compounds to influence the human brain, a challenge far greater than manipulating an insect. Manipulating an ant is one thing, controlling a human mind is another, a leap that would require unimaginable complexity. It would require countless mutations, 1,000 improbable steps, each one a roll of nature's dice. But in evolution, the improbable is never impossible. Nature has a way of surprising us time and again. The fungus wouldn't target us on purpose, it would simply adapt to survive, following the relentless drive of evolution. If the right mutations aligned, a new kind of threat could emerge, one that no one saw coming. The leap from ant to human is vast, but nature is full of surprises, and history is filled with the unexpected. In the grand theater of evolution, even the wildest scenarios can't be ruled out. Every act brings new possibilities. The question isn't just could it happen, but what if it did? In a world shaped by chance and change, we must always be ready to imagine the unimaginable. Picture the beginning of a nightmare. It starts quietly, maybe in a remote lab or a farmer's field where ancient ecosystems are disturbed. Patient zero might not notice the moment of infection, a scratch, a breath of spore-laden air. Days pass with no symptoms. Then, subtle changes, fatigue, headaches, muscle twitches, a strange craving for darkness. Doctors misdiagnose it as stress or a virus. The fungus is learning, testing its new host. As it multiplies, symptoms worsen, spasms, erratic behavior, blank stares, the infected wander, avoid sunlight and develop a clammy, pale skin. Family members realize something is terribly wrong. In the final stage, the fungus compels its host to climb rooftops, towers, trees. Driven by an alien will, the person locks in place, awaiting the fungus's gruesome finale. The transformation is complete, a human puppet, ready to spread the infection. The nightmare has only just begun. With patient zero in place, the true horror unfolds. Fruiting stalks erupt from the body, releasing billions of spores into the air. These invisible spores drift over cities, infecting anyone who breathes them in. Containment becomes nearly impossible. Spores settle on surfaces, food and water. Touching a doorknob could be enough. The fungus might evolve direct transmission bites or scratches from the infected. Airborne and direct contact, an unstoppable pandemic storm. Quarantines fail as the enemy travels on the wind. Every infected person becomes a mobile spore factory. Confusion reigns as officials scramble to identify the pathogen. By the time they realize it's a fungus, it may be too late. In crowded cities, the infection spreads like wildfire. Our interconnected world becomes the perfect network for doom. A mind-controlling fungus would shatter society. Fear and paranoia take over, trust evaporates. Governments impose lockdowns, soldiers patrol empty streets, daily life halts, schools and businesses close. The economy collapses, essentials become scarce. Power and water fail as workers fall ill or flee. People are trapped at home, haunted by sirens and silence. Isolation breeds despair and anxiety. Misinformation and conspiracy theories spread unchecked. Some deny the fungus exists, others turn to dangerous cures or cults. Social cohesion unravels. Violence and hoarding erupt. Fortified groups defend their territory, friend and foe become indistinguishable. Yet even in darkness, humanity's best shines through. Acts of bravery and sacrifice emerge. Communities share resources and protect the vulnerable. The apocalypse becomes a crucible, testing our character. We see the worst and the very best of ourselves. Survival depends on unity and compassion. Humanity fights back with a global immune response. Doctors and nurses risk everything on the front lines. Scientists worldwide unite, sharing data and racing to understand the fungus. High-security labs become war rooms, developing tests and searching for treatments. Engineers design air filtration systems and drones to contain the spread. New protective gear is rapidly produced. Governments and the WHO coordinate logistics, enforce travel bans and establish safe zones. Sometimes entire cities must be sealed off. The military aids in decontamination and infrastructure security. Technology becomes our shield. The world mobilizes as one, determined to identify, isolate, and neutralize the threat. Our collective willpower is humanity's greatest defense. The ultimate goal: find a cure, or at least a treatment or vaccine. Scientists repurpose existing antifungals, hoping for a breakthrough. Even one effective drug could buy precious time. Researchers design new molecules to target the fungus's unique biology. Blocking its mind control chemicals or dissolving its cell walls could be key. Meanwhile, teams race to develop a vaccine. Identifying a unique fungal marker could train our immune systems to fight back. The journey from lab to mass production is long and fraught with setbacks. Clinical trials, safety tests, and manufacturing billions of doses are daunting tasks. But relentless research and collaboration push us forward. Every small discovery brings us closer to hope. Our greatest strength is our problem-solving intelligence. Even with a cure, the world is forever changed. We enter an era of heightened biological vigilance. Thermal scanners and rapid detectors become standard in public spaces. Masks and protective gear are everyday accessories. Architecture evolves. Buildings with advanced air purification, cities with more green space. The pandemic forces us to rethink how we live together. We gain a new respect for microbes and the balance of ecosystems. Deforestation and environmental disruption are now seen as existential threats. Society remembers the lost. Memorials, stories, and art reflect the trauma. A new generation of scientists and public health experts rises. The crisis transforms our relationship with science and preparedness. We learn, at great cost, that prevention is priceless. Under the vast night sky, life on Earth appears fragile, yet it is remarkably tenacious, persisting against all odds. We are the product of 4 billion years of survival, shaped by countless challenges and evolutionary leaps. A zombie fungus would be yet another test in our long, unbroken history of adaptation and resilience. The fight would demand unprecedented global cooperation, borders and politics set aside for the greater good. Scientists, doctors, and communities would unite, sharing knowledge, resources, and hope in the face of adversity. This crisis would forge a new sense of global identity, reminding us of our shared humanity. Our greatest strengths are our minds, our compassion, and our ability to work together even when times are tough. Empathy drives us to care for the sick and vulnerable, ensuring no one is left behind. Curiosity leads us to search for answers, to experiment, and ultimately to discover a cure. Organization and communication help us rebuild what is lost, restoring hope and stability. We are the universe made conscious, able to reflect, to learn, and to choose our response to any challenge. The story of a zombie fungus is not just horror, it's also a story of hope, courage, and possibility. Even in darkness, the human spirit adapts, innovates, and endures, finding light where others see only shadow. We are the descendants of survivors, problem solvers facing the unknown with determination and creativity. Together, united by